ISA, the instruction set architecture, is an interface between software and hardware. Therefore, the assembly program and compiler assumes and hardware promises. There exist many ISAs. To name a few, we have x86, which is a dominant laptop desktop ISA, and ARM, which is a dominant mobile ISA. MIPS, PowerPC, and Alpha. ISA is a portion of computer visible to assembly programmer or compiler writer, and it's a standard for hardware design. Why do we have different ISAs? The answer is because we have different target workloads. Desktop ISAs are designed for performance of various programs. Server ISAs, such as database, file, and web server, do not need powerful floating point operations. For mobile and embedded ISAs, the energy consumption, code size, and memory footprint are more important factors. What does ISA include? It includes many different things, such as machine instructions, memory architecture, core, the interrupt exception handling, access control, priority and privilege, I/O method, task thread management, power and thermal management, multi-threading support, and multiprocessor support. You can download a x86 ISA document from Intel or AMD website, and it's several thousand long. Let's talk about macro versus micro architecture. The ISA, which is the interface between software and hardware, is considered as a macro architecture. The microarchitecture is an implementation of macroarchitecture, and it is not visible to the software. We have a good analogy. Gas pedal, which is an interface for acceleration in a car, is a macroarchitecture. An engine, which is an implementation of acceleration, is microarchitecture. Microarchitecture can vary as long as it satisfies macroarchitecture. For example, x86 ISA has many implementations, such as Intel Ivy Bridge, Skylake, AMD Bulldozer, and Ryzen. Here we compare high-level versus low-level versus machine code. High-level programs such as C is compiled to low-level program such as x86 and assembled to x86 machine code. Machine binary code can be disassembled to low-level program and decompiled to high-level program. However, perfect decompilation is nearly impossible. x86 ISA dominates laptop, desktop, server market. Major manufacturers are Intel and AMD. x86 provides backward compatibility up until 8086, which was introduced in 1978. More and more features has been added to its design since its introduction. Here is a brief history of Intel x86 processors. The very first 16-bit x86 processor, 8086, was introduced in 1978, which ran at about 10 MHz and implemented using only about 29,000 transistors. Next, 286, which supported Microsoft Windows for the first time, was introduced in 1982. In 1985, the first 32-bit x86, x86 was introduced that was running at 33 MHz. It was fabricated with 275,000 transistors, approximately. In 1993, the Pentium processor was introduced that was fabricated using 3.1 million transistors. Pentium MMX was introduced in 1996 and Pentium 4 was introduced in 2000. In 2004, the Intel released the first 64-bit x86 Pentium 4F. In 2006, Intel introduced the first multi-core processor, Core 2 Duo. Here is a die shot of quad-core Intel i7 x86 processor. There are 4 cores in the middle, along with a shared L3 cache. There is also an embedded GPU on the left and other modules. When it comes to the number of transistors on a chip, we have very well-known Moore's law. So Moore's law says that the number of transistors on a single chip doubles every 18 to 24 months. It implies that the computing power of a single chip also doubles every 18 to 24 months. Let's talk about another x86 design company, AMD. Historically, most of the time, the AMD just followed behind Intel in terms of performance and market share. Their major selling point was a lower price. However, AMD made a great contribution when we transited to 64-bit in year around 2003 and 4. There's an interesting story between AMD and Intel around 64-bit x86 transition. When industry transited to 64-bit in 2003 and 4, the Intel attempted a radical shift to totally different architecture called Itanium. However, the performance was disappointing. At the same time, AMD stepped in with the evolutionary solution which became the industry standard later. The Intel felt obligated to focus on the failing Itanium project because it was hard to admit their mistake or that AMD is better. In 2004, the Intel announced EM64T extension to Intel Architecture 32, which is almost identical to x86-64 that AMD proposed.